And this brings us to Newton's third law of motion. For every action, there is an equal and opposite reaction. This is another famous one, and really what it's saying is if you push on something, it pushes back with the exact same force. And really, kind of the key thing here is that forces come in pairs, right? You're never just pushing on one thing and not getting a force back from it. So when you push off the ground to go skateboarding, the ground pushes off of your foot as well. We call these action-reaction pairs. Sometimes these force pairs are very noticeable and they're going to cause motion in both of the objects, right? So when you fire a gun, right, the bullet goes forward and the gun goes backwards. It's called recoil. When you're ice skating and you push off of a friend, right, you're both going to go backwards. And so those are times where that reaction force is noticeable and it causes motion. But sometimes it's more subtle. For example, when you're sitting in a chair, you're pushing down on the chair is pushing up on you. In that case, neither force is causing motion, but they're both there. Or when you're walking, right, you notice that you're moving because you're walking, but you don't notice that you're also pushing on the ground and the ground is pushing on you. So, when you're looking for action-reaction forces, there's a few guidelines. Both forces are always there, right? So that is important. There's always a pair of forces. They have equal strength and are opposite in directions. But here's the big one. They act on different objects, right? So when you push off the ground, one force is against your foot and one force is against the ground, different objects. Both forces are real and they can cause change in motion, but they don't always cause change in motion. The last thing we're going to talk about here is momentum and how it relates to Newton's third law. These force pairs are going to cause different types of motion in different objects. And so here, I think before we even get into the math of it, is an obvious example. If two objects with different masses push off of each other, they will go in opposite directions, but the one with more mass will have less acceleration. If two objects run into each other, this is called a collision, they exert equal and opposite forces on each other, but the effect of that force is not always the same. So for example, two hockey players, when they run into each other, the forces on them are equal and opposite, but if they have different masses, it's quite possible that the result is going to be the same. Something with a greater mass is not going to accelerate as much from that same force. Momentum is a quantity that we're going to look at in this chapter, which is defined as the mass of an object multiplied by its velocity. We use the letter P in this class. It's actually a Greek letter, rho, I believe, and it is equal to mass times velocity. Mass is kilograms, velocity is meters per second, so momentum gets units of kilogram meters per second. Doesn't get a fancy name, it's just a compound unit. The law of conservation of momentum states that as long as the objects interacting are not influenced by outside forces, like friction, the total amount of momentum is constant and does not change. In other words, the momentum before a collision is equal to the momentum after a collision. So you can use this to make some predictions, right? If you know the mass and velocity of each of the objects before a collision, you can predict what they will be after the collision. So for example, a skateboarder that is 40 kilograms throws a 1 kilogram ball to the left at 20 meters per second. 1 kilogram, 20 meters per second, so the momentum is negative 20. That means that the momentum of the skateboarder in the opposite direction is going to be positive 20. And that will mean that the 40 kilogram skateboarder must accelerate at positive 0.5 meters per second. So you can see, A, we need to ignore friction, and B, that the more massive object is not going to be affected nearly as much. There are two types of collisions that can happen. Elastic collisions are ones where objects will bounce off of each other and continue with their full momentum, and when we're doing our math, that's the one we're focusing on. But there's also this other type of collision called an inelastic collision. This is like a little more realistic in many cases, like when cars collide or people collide. They're not going to just bounce off each other. There's going to be some deformation where the objects change shape or squish, and some of that momentum, some of that energy is transferred between the objects in other ways other than their motion, like bending the car.